Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 5.1.4, which is Writing Quadratic Equations. This lesson builds a lot upon the last couple lessons where we realized that the X-Intercepts of a quadratic function provide a lot of information for us in terms of how to begin the process of seeing a quadratic and how now we're going to extend this into writing a quadratic. And so in problem 5-39, it says you know how to make a table from a quadratic function, but can we write an equation when given the table? So we have to write the equation for the table below, and we have to use the really important pieces of information. Now, I just talked about the x-intercepts, and I really do think that we should begin with that. And I'm going to go ahead and reverse engineer this idea for you all here, and that is that the x-intercepts are going to be -3, 0. And 2, 0. And what I'm going to do is I'm actually going to think of this in reverse, and I'm going to say, all right, in the last lesson we learned that when we solved using zero product property, we would set the equation equal to 0. So for example, we had something like, say, x minus 4 times x plus 1 was equal to 0 after we factored it. We got that x equaled, or rather that x minus 4 equaled 0 from this side of the equation, and we got x plus 1 equaled 0 from this side of the equation, and we got x equals 4 and x equals -1. Well, from here we were able to extrapolate that because x equaled 4 and because we let the y term equal 0, we learned that the x-intercept was 4, 0, and for the exact same reason, -1, 0 was the other x-intercept. I'm going to use this idea in reverse when it comes to writing the equation. Because my x-intercept is -3, 0, I know that x equals -3. So in my thought process, I'm thinking my factor, the factor that makes this true, is going to be x minus -3, or more simplified, x plus 3. And again, using that exact same idea here, with 2, 0 being my x-intercept, I know that x has to equal 2. That means that my factor is going to be x minus 2, and there you go. So these are my two factors of my quadratic. So what I'm going to do is I'm going to say y equals a, parentheses, x plus 3 times x minus 2. Now, for those of you wondering right now, hey, what's up with this a right here? It's a very legitimate question, and I just kind of threw it in there arbitrarily, but as we have been factoring and as we've been dealing with quadratics, you guys will often know that if I multiply this out, I'm going to get a singular x squared term, a 1x squared. But we have factored many quadratics that don't have a leading coefficient of 1. And so what this a does is it allows us to find what that coefficient would be. And so I'm going to go and remove this part here, and I'm going to show you how we use that a. And make sure you remember that part, because everyone seems to forget that when writing the equation of a quadratic. What I'm going to do here, in order to figure out what this a is, I'm going to plug in another coordinate, a third coordinate here. And for this, I'm going to choose something pretty obvious. I'm going to choose the y-intercept 0, -6. You can choose any one you want. You'll get the same answer. But in my opinion, make it easy on yourself. So I'm going to go and say, instead of y equals a times the quadratic, I'm going to say -6 equals a times all of the x's replaced with 0. So what I did was I literally plugged in 0 in for x and -6 in for y. And now I'm going to get -6 is equal to a, parentheses, 3 times -2, which means -6a equals -6. If I divide both sides by -6, I get a equals 1. So in this particular case, I know that y equals a simple x plus 3 times x minus 2 will be sufficient in terms of the factored version of the quadratic. If I wanted to see it actually multiplied, I would say x squared minus 2x plus 3x minus 6, and I would finally get y equals x squared plus x minus 6 as the quadratic that I am trying to factor, or the quadratic equation that I'm trying to write the equation of. So from here, again, it boils down to one simple idea. Identify those x-intercepts, get them, and then solve for the a term. And that's all we're going to do for this next example as well. So I'll go ahead and identify my x-intercepts right here. -5, 0, and 1, 0. So again, -5, 0, and 1, 0. What does -5, 0 tell me? It tells me I have an x value of -5, which means my factor is going to be x plus 5. And then same thing here, the x equaling 1 from the root of 1 comma 0. And then that tells me that my factor is x minus 1. So again, I'll go ahead and get the beginnings of this equation written, where it's a times x plus 5 times x minus 1. Got to figure out what that a term is. This is what we call stretch factor, and we'll learn about that type of transformation later on in the class. But let's go ahead and figure out another coordinate here. I think this 0, negative 5 is pretty good. So negative 5 equals a parentheses 0 plus 5 times 0 minus 1. That means I get a times 5 times negative 1 equals negative 5. So by inspection, you could say negative 5a equals negative 5. So at this point, you should already know that a equals 1. So what I have is y equals x plus 5 times x minus 1. And if I multiply it across, I'll get x squared minus x plus 5x minus 5. Minus 5. And so I get y equals x squared plus 4x minus 5 as my final standard form quadratic function. So hopefully that makes sense. We are just reverse engineering the idea. I'm going to do a couple more examples. Give me a second. I'll be right back. And in this example here, it says Gwen is stuck while trying to write the equation for the quadratic in the given table, and her teammate says, this looks like part A of the problem we just did, except all the y values seem to be doubled. How can that help us? Well, let's find out. Let's go with what we know. Let's go ahead and identify those x-intercepts here. So again, negative 3 comma 0, 2 comma 0. So x equals negative 3. So that means that x plus 3 is one of my factors. X equals 2. Which means x minus 2 is the other factor. Again, this is where the a part is going to start coming in more handy here. So y equals a, again, this unknown stretch factor, plus 3 times x minus 2. And so now from here, let's pick that third coordinate here. Again, y-intercept, why not? Anytime you have the chance to pick something that has 0 in it, I'd say that's a good bet, because 0 tends to make things pretty easy. 0 plus 3 times 0 minus 2. So what you have is a times negative 6 equals negative 12. Scroll down a little bit. If I divide both sides by negative 6, I'm going to get a equals positive 2. And so now from here, what this tells me is it tells me that my equation is going to be 2 parentheses x plus 3 times x minus 2, which I'm going to go and multiply this guy out first before multiplying in the 2. That just seems to make my life easier, I think. But, that's just me. Plus 3x minus 6. So these guys will combine out to become x squared plus x minus 6. Please don't forget the 2 that was hanging out there on the outside. So I got 2x squared plus 2x minus 12 equals y. And there is your standard form quadratic function. Again, this time with a scale factor of 2. That is why we have to solve for a every single time, just to make sure that the stretch factor is what we think it is. I'll be right back with the next problem. And in this problem here, the water balloon contest revisited, and we talk about impeccable, and this was the dude whose water balloon could only be tracked by a table, and even then the data was incomplete, so we had to kind of come up with the information on our own. But remember, we noticed that quadratics grow symmetrically. So if I can identify the vertex of the quadratic, then I can infer what the other points are going to be on either side of them. So while evaluating this table, I'm thinking it's clear enough that 725 is the vertex, because if you look at the 24s repeating and the 21s repeating, so if I was a betting person, I would say that a 10 is going to give me a 16. An 11 would get me a 9. And a 12 would get me a 0. And so in this case, I think the part that makes this problem a little more difficult is the fact that you have to infer what the other x-intercept is. But again, rely back on that symmetry of the parabola. Find the vertex, and you know that the points on either side are going to be the same. And so here we go. We're back at this position again, where we should be very comfortable by now. So x equals 2, so I've got x minus 2 as my factor. X equals 12, so that means I've got x minus 12 as my factor. So y equals, again, that a term, you're going to forget, don't forget. X minus 2 times x minus 12. Let's go ahead and multiply this whole deal out here. Actually, no, what am I saying? Let's go ahead and solve for a. And so I'll go and use, well, in this case, they don't have a y-intercept, and that's okay. Let's choose something that's actually pretty easy. I think small numbers are pretty easy to work with. So I'm going to say 9 equals a, parentheses, 3 minus 2 times 3 minus 12. And so let's go ahead and draw a little line right there. That way I can get some more space here. 9 equals a times 1 times negative 9. So that means that I'm going to get negative 9a equals 9. So if I divide both sides by negative 9, a equals negative 1, which should fall in line with the water balloon contest, right? We saw that happen. We expected all of our equations to be negative parabolas because the balloon is going up and then coming down. So that should make sense that the a term would be negative. Let's go and multiply that out. X squared minus 12x minus 2x plus 14. Don't forget that it's being negatived. And so x squared minus 14x minus, or rather plus, did I say 14 right there? I meant 24. 24. And that whole thing is being negative. So you could either leave it like that or you could distribute the negative. It's entirely up to you. I will choose to distribute the negative this time. And I end up with negative x squared plus 14x minus 24 as the final quadratic that describes Impeccable's balloon toss. So there you have it. Writing the equation from a table or even given coordinates, as long as those coordinates are the x-intercepts and something else, writing the equation of the quadratic should be pretty doable, at least for now, until we give you something a little more difficult. But otherwise, that should wrap up the lesson. As always, please feel free to leave comments or questions in the comments area, and I will see you in the next episode.